Hello, hello. Right now we are going to be looking at multi-step conversions. Involving molarity. Okay, and so we are going to go back to our conversion chart, which remember is, let me see, is it here? Oh, yeah, it is. This is on the first page of your mole book, okay? However, I'm just going to focus in on the sections that we've done so far because there's a whole lot of stuff on there. So we have moles. And of course, we can convert moles of a substance into many things. We can go from moles to atoms, as long as it's moles of atoms. We can go from moles of atoms to number of atoms. We can go from moles of molecules to the number of molecules. We can convert between atoms and molecules by using the particle ratio, which is the number of atoms per molecule. You just count them up. Count the number of atoms per molecule. And we can convert between moles and grams. Do you remember the conversion factor for going between moles and grams? Hopefully you remember that that's the molar mass. And how do we convert between moles and either atoms or molecules, depending on what we start with? We use 6.02 times 10 to the 23, whatever the particle is, particles per 1 mole. And now we're going to add on to the top of this. Lots of things are going to branch off here. So going upward, if you recall, we just learned that we can convert between moles and liters of solution. What conversion factor do we use to convert between moles and liters of solution? That's right, we're going to use the molarity, which is the moles per liter. Okay. Oh, and molar mass is, of course, the grams per mole. So this is where we're at now. So we could say, for example, how many nitrate ions are present in 15 or 150, because I've written 150 milliliters of 3.6 molar calcium nitrate, CaNO3 2. Oh boy. Okay, this is a big one. All right. Now, let's start by identifying a few things. We have how many nitrate ions. That is our unknown. So our unknown is we don't know how many nitrate ions. So you'll notice right off the bat, we're dealing with two different substances here, nitrate ions, and we're also dealing with calcium nitrate. So remember, as you go back and forth across your conversion chart, you have to be in the same substance. And if you want to make life easy on yourself, you're going to say the only time I can change substances is at the very end over here. I'm lying to you a little bit, of course, because you know about the mole ratio, which also allows you to convert between one substance and another, but I'm going to set that aside for the time being to make life simple. So the only place you can change from one substance to another for now is over here using the particle ratio. All right, so I don't know how many nitrate ions. Do I have some sort of initial quantity? Well, I have two numbers. I have 150 milliliters, and that's of calcium nitrate. But I also have 3.6 molar calcium nitrate. Which of those is my initial quantity? Well, remember, whenever you are given molarity in a question, when given molarity in a question, convert it into moles per liter. Okay, so we're going to rewrite our 3.6 molar as 3.6 moles per liter. And now that we have it written that way, it becomes quite clear that that's not our initial quantity, that is a conversion factor. So we have our unknown nitrate ions. That's our conversion factor, and because I've got two substances, I should really be very careful about saying I have 3.6 moles of CaNO3 2 per liter. I don't have 3.6 moles of nitrate per liter. I have 3.6 moles of calcium nitrate per liter. Be specific, because at some point you need to change from one of the substances to the other. That means that my initial quantity must be the 150.0 milliliters of calcium nitrate. And if you remember, what should we do if we are given milliliters? We should immediately rewrite it as liters. So our initial quantity then is actually, what we're going to use is 0.1500 liters of calcium nitrate. This one's a little complicated, so I'm going to map it. I'm going to say, what can I convert into what? I am starting with my initial quantity, 0.1500 liters of calcium nitrate. And so that is up here. Okay, that's right up here. I have liters of calcium nitrate, and that's where I'm starting. Okay. Now, I am wanting to finish with my unknown, which is nitrate ions. So somewhere way over here, we're going to finish with nitrate ions. And ions in our little chart up here actually correspond to atoms. So it's atoms actually, or ions. So I want to finish with nitrate ions. That means that the route I need to take is I need to go from liters of calcium nitrate to moles, and then I need to go from moles to, what do I have moles of? If I have liters of calcium nitrate, that means I'm finding moles of calcium nitrate. And if I have moles of calcium nitrate, that means I must be finding particles of calcium nitrate. I cannot change substances to nitrate until I hit the end of this thing. So that means I must be going over here to molecules of calcium nitrate. Okay. And at this point, then I can finally take that particle ratio and go all the way up to nitrate ions. So I am going to have how many steps here? There's going to be one step here, there's going to be a second step here, and there's going to be a third step here. So I'm going to have three conversions. The first one's going to use molarity, the second one is going to use Avogadro's number, and the third one is going to use the particle ratio. So we can go from liters of calcium nitrate to moles, and it has to be moles of calcium nitrate. we can go from moles of calcium nitrate to the number of calcium nitrate. And once we have found the number of calcium nitrate, we can then find the nitrate ion. So that's going to be step 1, 2, 3. So let's solve this puppy. How many nitrate ions are there in 0.1500 liters of calcium nitrate? Well, we have, let's see, we need to convert from liters, and this is a solution. This is liters of solution. So when we convert from liters of solution to moles, what happened there? That's crazy. We need to use the molarity. So we need to cancel liters and we need to find moles. Okay? And the molarity was 3.6 moles of calcium nitrate per liter of calcium nitrate solution. Okay, well, next, and do you see how I'm sticking calcium nitrate after everything so that I know that that's what I'm dealing with? All right, next we need to go to the number of calcium nitrate. So we need to cancel moles of calcium nitrate and find the number of calcium nitrate particles. And of course there are 6.02 times 10 to the 23 calcium nitrate particles per 1 mole. Moles of calcium nitrate cancel out. And finally, we need to find the number of nitrate ions per calcium nitrate particle. How many are there? Oh gosh, that's easy. There's 2. Okay, and now we take our whole thing here and we have to plug that in to a calculator, which I have not previously done, so bear with me here. 0.15 times 3.6 times 6.02 E23 times 2 equals 6.5016 times 10 to the 23. And sig figs, oh, just 2 sig figs there. That looks like my smallest one, so that needs to become 6.5 times 10 to the 23. And the only unit I have left at this point, because calcium nitrate particles cancel out, is nitrate, NO3 minus, ions. Alrighty? And that was a big long question. I will do another example involving bunches of conversions using molarity, but not in this video. That will wait for another one.